And I probably need to do this. Start window video, close that out. Come on, share, annotate. All right, now, so parametrics are, you've got one equation for x and one equation for y. This is section 6.3. And a new variable t that's in both equations. Okay. There's the t has what we call parameters. Okay, so we can call the variable t is a parameter, I guess, and then you can define it on an interval, which we will do. So like these have been defined on a specific interval. And I had you graph these in class. It's the exact same equation, but it's got 3 different parameters. So for instance, these were the 3. All right, so we started off with x equals t squared minus 2, y equals 3t. We went to our, which mode should I be in?
You should go down to the graphing area and click PAR.
Right, for parametric mode. Okay, so once we get our calculator in parametric mode, then we'll have the x1 and the x and the y1 and then we'll be able to put in our 2 different equations, and you know that the xt theta n button will produce a t for you this time instead of an x. Well, so if you start with your t min and t max being the -3 to 1, you get the picture on the far left. Okay, but if you do -2 to 3, you get the middle picture.
And then if you do the
-3 to 3, you get that picture.
The full thing and not a partial.
Well, truthfully, it could go even farther than that if you went from like -infinity to infinity. Okay? It's a sideways opening parabola, as you can see, but what part is important to us or important to this situation? Maybe t represents time, and I should start with 0. Maybe 0 is the only, 0 on up is the only important part, and all the negatives are useless to me. Like time before 0, that wouldn't be helpful. Eliminating parameters. Okay, as you can see in this example right here, to eliminate a parameter means that you're going to solve one of the equations for t. And so you can see in this example right here in the middle in the blue, and here we'll do this. Ooh, I wonder what happens if I do this. Oops, no, come on. Do that. And ooh, right here we can use like a highlighter. Okay, so right there is the first equation solved for t, or the y equation solved for t. All right, and then we decided, hey, we'll take this and we'll plug it into the x equation right there for t. All right, so when we did that, down here in the blue, you can see that part right there where we put it in parentheses right here, and then distributed the -2, and so we ended up getting an equation, and we solved it for y, and so there was no more t's involved, and once we solved it for y, we ended up with this equation, which of course is a line, slope 1/2, y-intercept 3/2. Okay, so that's all you're doing when you're eliminating the parameter. You solve one equation or solve one.
Yeah.
Now, could I have done it a different way? Could I have said, okay, so I'm going to take the first equation, I'm going to solve it for t, so that'd be x minus 1 equals -2t, and t equals, what do we got? X minus 1 over, oops, not that, x minus 1 over -2. And then could we have substituted that into the other equation? Y equals,
a feasible option.
Sure, 2 minus x minus 1 over -2. We just have to know how to do the algebra
to make everything
work, right?
Yes.
So, there's nothing wrong with it. I mean, I'm eventually going to end up with that right there. Naturally. Anyway, oops, let's do the clear button. And let's go to there. And then we'll scroll down. So here's another one of those eliminating parameter questions. Okay. where we did the same type of thing. Now, the kids suggested to me that we took this equation and solved it for t. And so we did. We got y over 3. And then we substituted that into the other equation right there for t. Squared it.
Did all the good stuff.
Solved for y. Yeah. Now, solving for y in this case did involve a plus and a minus when we took the square root, which, some kids remember that, some kids don't.
Right.
But
so if you were to graph this, you kind of have to do two equations unless there's that sort of function on your calculator, which, I mean, there might be, but
well,
I don't know if there is.
You'd actually have to do two separate things. There is no plus and minus on a graphing calculator. Well, Desmos could handle it, but not the grapher. Now, that is, we could look at this. Y equals plus and minus the square root of, if I pull a 9 out, that would be x plus 2. Okay, and so then I could rewrite that. Y equals plus or minus 3 times that, which another way to write that would be y over 3 equals, this would be more like the fireproof form version of it.
Yes.
So you could see that there was a vertical stretch by 3. There was a left shift by 2. And this is so it went over to the left 2. You've got the right half and the left half. Okay?
Yes.
That's a square root, though. Not a parabola. What am I thinking? You should stop me.
I wanted to see how long you were going to go.
Oh, yeah, you wanted to watch me fail. There we go.
No, it's all right.
There we go. And finally got it.
I don't want to see anyone fail.
Nah, I'm just kidding. I know you don't.
Besides, I failed a lot.
You got a good heart, kid. Okay, so eliminating the parameter with this is a little bit different, right? Because you've got, instead of solving one of the equations for x or for t, you have got to realize that what you're doing is you are substituting into this equation. All right, so that's a different type. This is a circle. Even if you would graph that even in parametric mode, you would find that you had a circle. Okay, so notice what we did. We substituted x with 2 cosine t and 2 sine t. We squared them.
Had to square everything, which would be.
And what can you pull out of these two terms? What's in common that you can pull out?
The 4.
The 4. Okay. And so now if you do that, if you pull out the 4,
you get that, which is 4 times 1, and then r squared is going to equal 4.
Yeah, a lot of kids.
Of the Pythagorean identity.
Right, a lot of kids don't. I'm glad you recognized that. So that meant r squared was 4, and we know that r squared is this.
All right, so
that was the basic equation: x squared plus y squared equals 4. We were trying to do all that to figure out what r squared was. So,
or you could just go on Microsoft Excel and do it for you.
Oh my goodness. Yeah. Okay. We skipped example 5 because example 6 was basically the same.
Yeah.
Finding parametric equations for a line segment. Okay, so we had to find this. Yeah, we had to find the slope. Okay, so we found the slope. All right, and that ended up being 3 over 5. Right there, we can see that 3 over 5. Okay, and what I was trying to show you is that these are variables.
Right.
These are numbers.
Just like in the point slope form a little bit.
Yes. Now, you can choose whether you want this one or this one. It doesn't really matter. We picked, I don't know who did this in class. They must have just said 3, 6. So we did that. We put 6 in for y1 and 3 in for x1. Now, one of the key things is right here. We took our slope and we multiplied by t over t. Okay?
All right.
And then we did our substitution for y1 and x1.
Yes.
Then we have two separate equations. We have equation number 1 right there.
And equation number 2 on the bottom.
Yeah. Okay, and then we can set these up down here, and we can start solving them. So we get y and x by themselves. So that's 2/3 of the work.
Right.
The last part of that question is actually finding the parameters of t. So you have to pick x or y. It does not matter whether you pick x or y.
Right, because you're going to get the same answer no matter what.
Correct.
As long as you do the stuff in between right.
Right now, it looks like in class they chose y.
All right.
And I know that because of what I see right here. All right, now, how did I get the 3 and the 6? I went back up to the top.
B values in both equations.
I went back up here to the top, and I saw that I had 3 and 6
as y coordinates.
as the y coordinates.
Now, if you would have chose x, would you have done the x
Yes,
coordinates?
-2 and 3.
And then you just subtract them.
Well, now wait a sec. I just needed the 3 and the 6, so I just picked them off. Now I come here down to the bottom. That's where I have my 3 and my 6.
Yes.
Okay. Right there and right there. And then I substituted. Now where did I get that substitution from? Right here.
In the y equation.
Now if I had used the -2 and the 3 for x, then I would have been substituting with that.
But
it's up to you which one it doesn't really matter. You'll get the same parameters. And so then I was able to do the substitution, subtract the 6 from everything, divide the 3 to everything, and end up with my final parameter for t.
1, t, 0. No, -1 is less than or equal to t, which in turn is less than or equal to 0.
Okay. Now that was the end of part of 6.3a. Do you have time?
No, I do not.
Okay. All right. The baseball question is something you should watch.
Yes.
Watch the baseball question. There will be a baseball question on there, okay?
All right.
Nothing, and so you need to, now all these equations will be given to you.
All right.
All right? So, but you just need to be able to plug the things in that you need to in order to figure out
all right.
the solution. I'm not going to have one of these questions on there. Okay?
Excuse me.
So don't worry about example 10. Okay.
All right. Thank you.